Hello. Streamlining EDA design and code generation with PubSub Plus Event Portal and Async API. That's the topic for my session today. My name is Giri Venkatesan. I'm a developer advocate at Solace. Right? As developers, we strive for this design with precision and tested to perfection to ensure reliability, efficiency, and improved user experience. But it's important to recognize the complexities and challenges involved in real world applications. This is particularly true and complex in the context of event driven systems. All right. There are many challenges, but let's focus on the key challenges here. Number one, complexity of asynchronous interactions, concurrent processing, error handling, and unpredictability around ordered processing are serious issues. When it comes to event handling, any event loss or duplication is a clear risk. Unlike synchronous systems, event-driven interactions lacks immediate feedback, complicating real-time verification of correctness. Right? And then standardization is a crucial aspect, which helps you document and test system-wide interactions in an event-driven design. Without it, sharing, reuse, and testing can become significantly more complex. Integration testing, scalability testing, performance testing, and so on in an event-driven system is challenging due to loose coupling and asynchronous nature of interactions. The first three can be mitigated by employing a robust event broker like Solus Plus Broker, and the remaining two can be mitigated by adopting a standards-based approach for documenting the asynchronous services. Use of Async API as a standard for documenting your event-driven applications not only helps documentation, but also in code generation and testing with its rich set of tools. We will dig in further. The emergence of event portals. It's a good idea to examine the established architecture like RESTful architecture against the emerging event-driven architecture. From runtime perspective, an API gateway acts as an entry point for clients to interact with various providers and supports routing, managing, and optimizing API requests. And in an event-driven architecture, an event broker, which is a middleware component that facilitates communication between producers and consumers using events. It's comparable, right? In a design time scope, the RESTful architecture utilizes API portal that facilitates collaboration, design, documentation, and access to APIs. That leads to catalog capability, documentation capability, discoverability, share and reuse, analyze, extend, and design new APIs by composing new API from existing ones. Last but not least, with the adoption of standards like OpenAPI, you can even generate code and build test cases, right? Event-driven architecture needs a similar design capabilities. This is where Event Portal comes into picture. It offers functionality similar to API Portal, but works with events, schemas, and applications, offering similar capabilities, a catalog of events, discoverability of events that in your enterprise, and share and reuse of events, analyze, extend, and compose new events from existing ones, and enter Async API, the widely adopted standard for documenting asynchronous services with its rich toolset, making it possible to generate code as well. Right? So, according to Forrester, a simple definition of event portal, it's like an API user portal, provides a place for event publishers and event consumers to connect and collaborate on event usage policy and subscription to event streams. Sounds good, right? So Solace pioneered the event portal space with introduction to PubSub Plus Event Portal, which lets you design and organize the building blocks of your event-driven system as manageable design artifacts. Now, it starts with the application domain, which is nothing but a manageable section representing different business lines, development teams, or logical categories within your enterprise. An application domain can have one or more applications, which are simply runnable entities like a program, process, microservice, IoT device, integration component, and so on, that it produces, consumes, or process events by interacting with an event broker. Right? The central building block here is event. An event is an object that defines the properties that describe and categorize an actual event instance at runtime. Right? So an event instance is a single occurrence of an event message that is produced by the producer. Right? And of course, it carries a payload carrying business information. Right? This information has to have a formal agreed structure. The schema defines the structure and meaning of each data value in the payload of an event so that the publisher and subscriber comes to a common understanding as to what each value means. That's great, right? It also offers a self-service access to data and helps you know what's going on in the runtime and govern accordingly. Not just that, also helps you to visualize the event flow in your event-driven systems, right? The What you see here is a connectivity between applications in terms of events published and events consumed. Okay? How the users interact with Event Portal. To answer this, let's look at the persona. Who will benefit from Event Portal. Architects use the Event Portals to define, discuss, and review events, data definitions, and application relationship. And developers use the Event Portal to discover and understand, reuse events when building applications, right? Um, so these applications could be serving a line of business or between external organizations more easily. And comes the third persona, data scientists. They use the event portal to better understand the event-driven data and discover new insights by combining events that can help the enterprise. Right? That's from the user interaction perspective. Now, the event portal helps the enterprise take their great event-driven idea and make them reality for the user. It's a continual journey, something that's now faster thanks to better event reuse and collaboration, and more efficient with the automated access to events, and one that doesn't break things simply because the guardrails like versioning, lifecycle, and policy enforcement are made available in the event portal. What you see here is the phases of your journey: discover, design, authorize, promote and deploy, audit, and improve. We'll look at them a bit more closely. Unearth the event-driven stuff that you didn't know existed. Basically, Event Portal catalogs all the assets of your event-driven architecture in one place. And once the assets are found, you can instantly understand how everything interacts, what applications are in use today, and what is the data format that's put in place for this event, and how to access the events. That is your discoverability, right? And then once the right mixture of events are uncovered, it's time to design. Since collaboration is the key, every functional area is assigned a domain for itself, which breaks the larger enterprise into bite-sized pieces for better access, control, and focus. Okay. Event Portal users also offers a drag and drop canvas to create high-level designs, allowing the developers and architects to collaboratively create and modify the application interfaces. Event Portal makes it easy to compose solutions using a mixture of events from outside the domain as well as inside the domain. What you have is a collaborative approach to designing an event-driven system. All right. Authorization at play. Rest assured, you have full control over event access. So you're just sending and receiving events within your domain. Approvals don't matter because that's already within your team structure and there is no more permissioning required. If it is outside your domain, you need a permission workflow. The event owner is the best person who can get to review the request and approve or deny access to the event based on the context, right? So that's your authorization, authorized access, right? And exactly the events you need when you need them. What does it mean? Let's say the team designed something amazing. How does the solution get the events it needs at runtime? Because Event Portal focuses on design time, right? Now the question is, how does the solution get the events it needs at runtime? The Portal supports the notion called as provisioning. Provisioning just the events the application needs only when it is moving into an environment, what we call as just-in-time provisioning, something that can be controlled through Event Portal. It starts with the pinpointing which applications moves to which environment, and applications are designed once and implemented consistently across the environments, right? It's all about provisioning. Essentially, a consistent way of provisioning and deploying design time artifacts into environments. That's your broker slash runtime. Okay. The term security assessment can strike fear into teams everywhere because a runtime and design time representation can go out of sync for whatever reason, as changes are made continuously, right? The event portal's audit capability interrogates the runtime, that's your broker, no matter where they are, and ensures everything stays synchronized. So basically, it closes the loopholes that allow people to bypass governance so that you can authoritatively know that developers are correctly implementing based on the design. Okay. Now, offers a wonderful side-by-side comparison of inferred changes in the design versus runtime assets and potentially allows you to sync the design quickly with the observed changes. Event-driven assets are auditable. As always, the stakeholders want a clear return on their investment, right? Questions around what are your most used events? What events do people not care about? And most importantly, are you getting a good reuse of your events, right? These are some questions that can shed light on the effectiveness and the efficiency of your design. One of the best things that API management introduced was key performance indicators, right? Event Portal brings the KPIs into the event-driven world. A least reused event could use a bit of a promotion or advertisement to increase reuse, for example. Event Portal offers an iterative process for continuous improvement. So that sums up the Event Portal capabilities and the whole journey of how to build an event-driven architecture. Then comes async API, the superhero we didn't know we needed for taming this async chaos. Everybody would know, I'm pretty sure, async API is the emerging and industry standard for defining asynchronous APIs. If you need more information, feel free to check out the Async API Initiative website, full of beautiful, wonderful content. And with that, let me move to how the event portal and async API come together to realize this design to documentation. As mentioned, we're going to break down this requirement into application domain, application, and design events, and design the schema. At the end of the day, it comes to application. That is the one that binds the events to an application with appropriate permission set, like publish or subscribe, right? So on those applications, you should be able to download an async API documentation of the service. The moment you get the async API document of that application, now you can tap into the full capability of async API ecosystem. As a starter, we can put it through code generator, and that means you don't need to copy paste anything anymore, right? These code generators exist for various languages, starting from simple JavaScript, Node.js, Java Spring, Java Spring Cloud Stream, to many, many languages. Python, for example, right? And there exists iPaaS native generators that can create flows and necessary code to integrate or deploy in iPaaS platforms like Boomi, SAP, and MuleSoft. The Async API generator tool is your best friend for generating code. With a rich set of binders for all popular programming languages, it makes life easy for developers. Okay? The event portal, the one that we are discussing today, acts as a centralized hub for designing, managing, and governing event-driven architecture, while Async API provides a structured format for defining and documenting the event interactions. So basically, a complementing capabilities that can work together to realize event-driven implementation. Right? Here's how the event portal's assets map to corresponding async API elements. An application maps to application, and a broker configuration and event portal maps to servers element, and topics maps to channel, events maps to messages, schemas to schemas, destination to binding. You see the full picture, right? So there's a lot of parallel in terms of how the event portal builds the design of an event-driven system in terms of application domain, application, and so on. And then how the async API captures this asynchronous service or asynchronous application, right? Basically, we are looking at streamlining of design and implementation of an event-driven system, starting from event portal for design to async API for code generation. All right. I want to take it to the next level. Talking about code generators, though we have plenty, I want to pick Spring Cloud Stream as an example for our discussion today. So, what is Spring Cloud Stream, right? Let's take a step further. Spring Cloud Stream is a framework that abstracts many messaging systems like Solus, Kafka, RabbitMQ, enabling developers to focus on building business logic rather than handling the middleware complexities. Right? It also offers binder abstraction. That means it simplifies the integration with different messaging systems. And coming from a Spring ecosystem, it allows you to easily integrate and leverage other Spring capabilities like Spring Boot, Spring integration, Spring security, and various other Spring features, right? Inherently designed to be event-driven, the framework supports annotations, making it easier to develop, test, and maintain the code that's the final result, right? And the Spring Boot's auto configuration and dependency management, as always, significantly minimize boilerplate code and configuration overhead. Okay. And Spring Cloud Stream's configuration-driven approach aligns seamlessly with Async API. Basically, the Async API is contract-first design, enabling a direct mapping of Async API specification to event-driven microservices represented by Spring Cloud Stream. Let's look at how things map out. Now, let's take the Async API specification, the elements, and see how it maps to Java Spring Cloud Stream configuration elements. The servers to binder configuration, channels to binding, messages to message payloads, operations to input-out binding. There we go, right? Async API, with its structured approach to defining event-driven APIs, aligns perfectly with the Spring Cloud Stream's configuration for binding application logic to messaging system. This correspondence helps streamline the development and configuration of the runtime event-driven microservices. Okay. When you find time, please check out this repository. Basically, a conceptual coffee shop application domain having 5 different applications, like a third-party app to get orders from mobile and web front ends, and then an order management system, a barista station, kitchen floor, inventory system. These are the key applications that makes up the coffee shop application domain. And as you see the arrows, the events represents the flow from one application to other application in terms of publish and subscribe settings, right? This repository has examples implemented for order management system and barista system, right? Do check out this code, and it will give you a better idea, starting from event portal application to async API document to Spring Cloud Stream microservice. Okay, that's a journey we are talking about. Takeaway: the combination of async API, PubSub plus event portal, and optionally, if you choose to work with Spring Cloud Stream, that's great, offers a simple yet powerful means for designing, developing, and managing event-driven architecture. All right. So my recommendations: adopt async API. Number one, embrace async API for its robust specification and structured approach to defining event-driven services. This ensures clarity and consistency across your development lifecycle. Right. Number two, utilize PubSub plus event portal. What do I mean by that? Leverage the design and management capabilities of Solus event portal to create, document, and export your EDA applications as async API documents, which then goes through the seamless transition from design to implementation and so on. Right. Employ code generators. Use async API code generators to automate the creation of boilerplate code for frameworks like Spring Cloud Stream or any other language of your choice. This approach not only accelerates the development and ensures alignment with the defined specification, but also significantly boosts developer productivity by reducing the manual coding effort. Something very useful you can kind of shorten your development life cycle. And last but not least, optionally, integration with Spring Cloud Stream. If you choose to work with Spring Cloud Stream, that's a perfect match. Implement your event-driven services using Spring Cloud Stream to benefit from its abstraction over multiple varieties of messaging systems, ease of configuration, and integration with the String ecosystem. By following these recommendations, you can harness the full potential of Async API and PubSub Plus Event Portal, leading to more efficient, reliable, and scalable event-driven architecture. So that's a wrap from my side. With You can connect with me on our Solace community, which is solace.community, or connect with me on LinkedIn. Would be happy to